Everyone, this is lesson 3.3 in the Algebra 2 textbook on simplifying expressions with conjugates, radical expressions specifically. So we're going to do a few warm-up questions just to review some basic concepts of adding and multiplying radicals together. So first of all, when you add radicals together, they're kind of like terms. Like you can only add two radicals that have the same root and the same number under the radical. So here, since these both have the square root of 3, we could say, well, 8 square root of 3 plus 5 square root of 3 is kind of like 8 apples plus 5 apples is 13 apples. So they have to be the same. So 13 square root of 3 would be the final answer simplified. Okay, so for this one, they're both the cube root of 5. So we're good here. We can say that this is negative 4 cube root of 5. And then you wouldn't change what's under the radical either if you're subtracting them together, kind of like how exponents work too, because radicals are just a different form of exponents. So for this one, it doesn't look like these are the same initially, but remember that the square root of 12, we can simplify that. That's not in simplest radical form. So the square root of 12 can be written as 4 times 3. So you would pull out the greatest perfect square from 12, which is 4, and then the 4 can come out as a 2. So then the 4 comes out as a 2, then instead of negative 8, you'd have negative 16 because you're multiplying it by 2. Square root 3 plus square root 3. So then this would be negative 15 square root 3 because you're adding 1 square root 3. All right, and for this one, so remember that with the 8, the cube root of 8 would come out as a 2. And then if you have 4 x's under the cube root, that means one of the x's will come out because it's like x to the third times x. So one of the x's, the x to the third will come out as an x, but this x will stay. So we'll have an x out here and then an x, cube root of x left over. For this, we can just bring out the negative sign because the cube root of a negative is just negative. So the cube root of positive x. So our goal here is really just to make all the radicals the same, if possible. And then this one, the cube root of 27 comes out as a 3. So then we have 4 times 3, which is 12, cube root, and then the x is just going to stay. So then we've got 2x cube root of x. That actually can't add up with these ones because these don't have the x with them outside of the radical, but we can combine these two together. This would be positive 11 cube root of x, and then we'll just put in a 2x cube root of x in the front. All right, and this would be highest to lowest power, like standard form, because this has a higher power than this for x. Okay, and then a few more. We're not going to do all of these. We'll do this one, I guess. So when you distribute this, you multiply the 3 and the 2, so that'd be 6. And then this would be 2 times 8, which is 16. And then this would be minus 3 times the square root of 2 times 3 is 6. And then the square root of 16 is 4. So this comes out as a 4 times 6, which is 24, minus 3 square root of 6. All right, and then for this one, notice that this is a difference of, not a difference of squares, but this is one thing plus and then the same thing but minus. So these are actually called conjugates. This is where we're going for in this lesson. So we're going to go ahead and FOIL here. So we'll do 2 times 2, which is 4, 2 times negative, or 2, yeah. So this is negative 2 square root of 5, and this is positive plus 2 square root of 5, and then square root of 5 times square root of 5 just turns into 5, but it's minus 5. So then you have 4 minus 5, which is negative 1. And then these two cancel because you have the same thing, but one's negative and one's plus. So those are going to cancel, and you're just going to be left with negative 1. Okay, and then the same thing is going to work out here. So when we do the outer and the inner term, well, first for the first term, we'll have 16. The outer and inner term are both going to be 4 square root 7, but they're going to be opposite signs, so they're just going to cancel. And then the last term will be just negative 7, and this gives us 9 for our final answer. So that brings us to the definition of a conjugate. The irrational numbers a plus square root b and a minus square root b are called conjugates. And when multiplied together, it will always yield a rational number, as you saw in the other examples, right? So I think I did a plus square root b times a minus square root b. So this will turn into a squared, outer and inner terms cancel, and then just minus b, for example. And we use this because when we're dealing with radicals and rational exponents, we're not allowed to have a radical in the denominator. So we've done this a little bit before. Oops, I'm messing this up. When we were working with special right triangles, is to rationalize the denominator. So to rationalize denominator means to find an equivalent fraction with the denominator that is a rational number. So if I have 1 over the square root of 2, I can multiply the numerator and denominator by the square root of 2, because whatever you do to the numerator, you have to do to the denominator. So this would turn into the square root of 2 divided by 2. Now for this one, if I have the fourth root of 25, well, we have, first of all, we have 5 times 5 in here. So if I want to have 4 5s, I would have to multiply again by the square root, or the fourth root of 25. So I'm going to do the fourth root of 25 over the fourth root of 25. So this turns out to be 2 times the fourth root of 25 divided by, and then the fourth root of, this turns into 625 is just 5. And then if you can simplify the numerator and denominator, you can, but here we can't, so we'll just leave it like that. All right, so some examples. So here, 2 over the square root of 5. So this one is just one of the easier examples. We're just going to multiply the numerator and denominator by the square root of 5. So we get 2 square root 5 over 5. We can't simplify, so we'll leave our answer like that. For this one, you have, actually, I feel like I skipped one. Oh, there we go. Okay, so we have the cube root of 3. So I need 2 other 3's to go into this so that it can come out as a 3. So this would be 9. So I'm going to multiply the numerator and denominator by the cube root of 9. So you want to just basically make it into a perfect cube, or a perfect whatever the root is. So we'll have 10 cube root of 9 divided by, and this is just going to turn into the cube root of 27, which is just 3. So that would be that answer simplified. So we don't want radicals expressions in the denominator. Okay, so now we're going to get to the point where we'll use the conjugate. Actually, wait, this doesn't match with, not sure where this example came from. But, oh well, we'll go ahead and try this one. So what would you have to multiply by here to simplify the square root of 3? This is just a basic example, so we would just do the square root of 3. You don't have to worry about multiplying by 2 again. So we would have, this one you have to distribute. So you have to go like that and that. So the square root of 3 times square root of 3 is 3 minus 9 square root of 3. And then over, this is going to be 2 times 3, so 6. And then here you can actually, since you can simplify 3 and 6 and 9 and 6, you can separate your terms. So like 3 over 6 minus 9 square root 3 over 6. So this turns into 1/2 minus 3 square root 3 over 2. And is there an example down here? No. Do we get to the other examples that are actually in the notes? Not quite. I'm just going to add the examples that were from the notes. So we'll do 2 over 4 plus square root 11. So here I would multiply by the conjugate if it's something like this. So I'm going to multiply both sides, both top and bottom, by 4 minus square root of 11, 4 minus square root of 11. So here I'll distribute. So this would be 8 minus 2 square root of 11. And then here I'm going to FOIL. So I'm going to have 16. Outer and inner terms cancel. And then the last is going to be minus 11. So this turns into 8 minus 2 square root 11, which I can't combine, over 5. Now, you can separate it if you want, but since these aren't divisible, you don't have to. The answer is in the Edulastic. If they want you to simplify it further, then they'll specify. Other than that, I have it set to either ways to write it. Okay, so we're just going to do the next example from the notes. Square root of 3 over square root of 3 plus 1. So here I would multiply by the conjugate, square root of 3 minus 1 over square root 3 minus 1. So this turns into distribute. So 3 minus the square root of 3, because square root of 3 times 1 is just the square root of 3. And then this turns into, if you FOIL, this turns into a 3. Outer and inner terms cancel, and then you do the last term. So basically, you're just doing the first and the last term when you're doing the conjugate. So 3 minus 1, which is 2. So we have 3 minus square root of 3 over 2. It's fine to leave your answer like that. Okay, and then we'll do one more example here. I'm not going to do some of the more complicated examples. I would have, actually, we'll do 2 more things. All right, let's do this one. So negative 3 plus the square root of 10 over 2 plus the square root of 10. So here I'm still multiplying by the conjugate. So 2 minus square root of 10 over 2 minus square root of 10. So this one, though, we have to FOIL all the way. So for the numerator. So negative 3 first terms gives us negative 6. And then the outer terms gives us positive 3 square root 10. And then this term gives us plus 2 square root 10. And then the last is going to give us minus 10, because the square roots will cancel out. And then divided by, we'll simplify that in a minute. And then the conjugates, we're just going to do the first and the last. So 2 times 2 is 4, and then minus 10. All right, so let's simplify some things here. We've got negative 6, and we have negative 10, make negative 16. And then 3 and 2 make 5. So 5 square root 10, because we can add those together since they both have square root of 10. And then this turns into negative 6. I'm at negative 6, not negative 16. So since negative 16 and negative 6 can simplify, we should separate the terms. So this would be 16 over 6 is 8 over 3, so we would have 8 thirds. And then this would be minus, because of the negative 6, 5 square root 10 over 6. So that's how you should write your answer for this one. Okay, and then we'll do one more to replace F in your note sheet. We're not going to do that example, don't worry. We could, but there's no need. We're going to do a different question. This one here. So it's 3 minus the square root of w squared. So this is just a friendly reminder that you don't distribute the square when there's a plus or minus in the parentheses. You have to first rewrite it as 3 minus the square root of w. So you have to double it, times 3 minus the square root of w, and then FOIL. Now this one, these are not 1 plus and 1 minus, so the outer and inner terms aren't going to cancel out. They're going to combine together. So let me show you. So go ahead and FOIL. So 3 times 3 is 9. Outer term gives us minus 3 square root of w. Inner term gives us minus 3 square root of w. And then the last term gives us plus, because you have 2 negatives, just w. So then this here, negative 3 and negative 3 is going to combine to negative 6 square root of w. But if I want to write this in standard form, I should write it from highest power to lowest power. So I'm actually going to put the w first, and then I'm going to put the plus 9 last. So there's a question in your Edulastic that will say, like, write it in standard form, and that's just what it means, because w to the first power is bigger than w to the 1/2 power, right? Because this is w to the 1/2 if you write it in rational exponent form. All right, so that is the end of this lesson. Hope you enjoyed it, and then next we will do a day of review for your quiz, and then you'll have a quiz on Friday. Okay, have a great day.